Okay, we are back like we never left. Okay, in our last video we did the y-x direction, right? So in this video we are going to do the xz direction, right? So the xz direction, because all these forces, they're not acting in one direction now, they're acting in different phases, so you have to consider all of them, right? So now considering the x and z direction. Now in the x z direction, one thing you have to realize, you don't know which direction the bearings are acting in, right? Like, you don't know which direction the bearings are holding the shaft, right? So we're gonna assume. So I'm gonna assume that R. Okay. I'm gonna this is A, and okay, this is Z. This is because I want you guys to understand. Now, first things first, we know that the tensions are acting downwards, right? Are acting this way. So I'm gonna say the acting, right? This is the tensions. This is tension 1 plus tension 2, tension 1 and tension 2 of the pulley, right? And then here I'm gonna assume that the bearing force is acting, the bearing reaction is acting upwards. I'm just assuming, I don't know why I'm assuming. And I'm also gonna assume that the bearing at C is acting upwards. These are assumptions, you don't know. And then this one, the tangential of the gear is gonna go down. We go down anything 0.12, like 0.08, and then 0.1. These are the distances, right? Distance, meters, meters, right? So this is going to be T1 and T2, and this is going to be the tangential load of the gear, right? This is A, B, C, D. This is going to be R, C, Z. It's going to be R, A, Z, right? So we have to solve for this reactions at bearings. Okay, right. So I'm assuming, like I assume that this one is going up, so it's going to be R, A, Z plus R, C, Z. If my assumption is wrong, like it's going to give me, when I'm solving either one of these two, they're going to give me a negative number. So that is when I'll say, okay, then my assumption was wrong. So, but then let's solve them, then we'll see. RAZ, RCZ is equals to tangential load of the gear plus T1 and T2. T1 plus T2, right? And then let's take moments to cancel one. Moments is equal to, I'm taking moments about what? You know what? Because we can do it. Let's just take moment about A. Okay, I'm joking. Let's take moment about C. Right? It's gonna be R A Z multiplied by 0.2 from here to here, right? And then minus FT, tangential load of the gear. We found it. I don't know where it is, but I know that I found it. I don't know where it is, but I know that I found it. The gear. I'm not talking about this. There's the gear, right? Which is 884, which is 884 4.167 multiplied by 0.08, right? And then this one is going down, so it's gonna be plus T1 plus T2. T1, I found it also. What is A? Yeah, T1 is 1131.73 plus, let's write it here, plus T2, which is 452.69, right? And then multiply by distance 0.1 is equals to 0, right? And then let's solve for RAZ. So it's gonna be 0.2 RAZ is equals to, I'm gonna punch everything here and then change its sign. So it's minus 884.167 multiplied by 0.08 plus 1131.73 plus 452.69 multiplied by 0.187, right? And I have to change the direction. I knew it. So it's minus 87.708 divided by 0.2. Therefore, RAZ is equals to 87.708, 0.2. That means RAZ is equals to, here is minus 438.54 Newton. That means here my assumption of direction was wrong. That means yes, this is the correct one. This one is wrong. That means here the bearing is acting downward in the same direction as the T1 and the T2, right? So let's find RCZ. RCZ is gonna be the tangential load plus the tension 1 plus the tension 2, which is the tangential load. Tangential load is 884.167, yes, plus 452.69 plus 1131.73. Yes, true. Okay, it's 2468.587, right? Minus RAZ, so it's gonna be minus is gonna be plus 438.54. That means my RCZ is equals to 2468.587 plus 438.54, 2907.127 Newton. Good. Very good, my boy. Very good. Amazing. Right now, sheesh. Now I'm done finding all the reaction. Now I can draw up the shear stress diagram. Why are you drawing the shear stress diagram? Because I can. I can. And if we can, we do. If you watch the Piggy Blinders, then you know this scene. I can. And if we can, we do. Okay, let's focus. So that means this bearing is the only force that is acting in the opposite direction of all these forces. Man, I want to talk about 100 things alone. Okay, so this is RAZ. I should have just written down. So it's 438.54, and here is FT, the tangential, which is 884.167, and here is 2907.127, 27, and here is tension 1 plus tension 2. Let me just add them all together. 1131.73 plus 452.69 is 1584.42, right? Okay, now let's draw this thing. Let's draw this thingy. This thingy, nigga. Let's draw this thing. Wait. My throat is dry. Yeah, let's go. Boom. And boom. Just as shear force PM W. Right, okay. Now let's look at this. This is 438.54, right? RAZ is here. 438.54. This mine is going down in a DM, but let's go down. So it's gonna be right, which is minus 438.54, right? And then right, and then here we minus is going down again. Minus 438.54 minus 884.167 is minus 132. Minus 1322.7. Let's put it here. And then you go, and then plus 2907 plus 127, which is 1584. Yeah, nigga, yeah. And then we're coming back to 0. You should always end up at 0. If you're not at 0, that means you're doing something wrong. All right, now let's write the bending moments, right? Bending moments, right? Add this A, B, C, and this is D. Add A, add B, right? And add C and add D. Add A is gonna be 0 Newton meter. Add D is gonna be 0 Newton meter. They all gotta start and end at 0, right? Bending moment at B is gonna be this one. It's minus 438.54 multiplied by the distance. I forgot to write the distance. 0.12, 0.08, 0.1. This minus 438.54 multiplied by 0.12. Yes, it's equals to, and then let's see, is minus 438.54 multiplied by 0.12. Hey nigga, don't make mistakes. 0.12, because those mistakes will cost you 0.2. Why? And then minus again, which is an 884.167 multiplied by 0.08. Yes, sir. Minus 438.54 multiplied by 0.12. This is minus 52.62 Newton meter, right? And then this is going to be 0.2 minus 884.167 multiplied by 0.08 gives me 1 minus 158.44 Newton meter, minus 158.44 Newton meter, right? So let's draw them up. Draw them up. Minus here at B is minus 52. 58.62, and then at C is minus 158.44, and then you're all coming back to 0. You're starting at 0. We almost there. We almost done, bro. We almost done. Hang in there. Hang in there. Hang in there, bro. Hang in there. Hang in there. So we have the moment here. Boom, 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 boom. Right? Okay. That means now we can calculate the resultant moments. The resultant moments. This was the XZ. XZ. Now look at this. Look how easy it is once you've done all the hard work. Once you've done all the hard work. If you watch the regular show, Mordecai has this saying that once you've done the hard things, they don't become hard anymore, right? So once you've done all this, it's easy to calculate the maximum bending moment. The maximum bending moments, how do we calculate them? We just add the resultants at B and the resultants at C and find which one is maximum. Yeah, Mordecai said it. I mean, Rigby said it, right? So this is the resultant moments, right? Okay, now, and then at B, right? And add C is equals to, right? So the negative sign, it doesn't matter. It's not going to affect because it's going to be finding the result. It's going to be in the square root, right? So let's start with which one did we find first? The exact of the x, this one's. Now we found this one's first, but then it doesn't matter. But then let me just start with this one. At B, the moment here is 13.135 squared, and then at C is minus 9.812 squared plus. Now we add the ones. These were ones in the y, these are ones in the z. The z is minus 52.62. This one is minus 158.44 squared, right? And they're all in a square root. They're all protected by the king square root, right? Maximum. Now let's find which one is the biggest, but obviously we can see, so already I can say that it's this one. 13.135 squared plus minus 52.62 is 54.23 Newton meters, right? And then at C is minus 9.812 squared, right? Minus 158.44 squared, which is 158.74 Newton meters. Yes, we almost done. Hang in there, we almost done. Now everything, like I said, once you've done the hard part, they don't become hard, so it don't become so hard anymore. Now everything, that means we're gonna use what is the maximum? The maximum bending moment is at C, so that means we're gonna use this one. Yeah, the small ones, we don't give a fuck about the small ones. And the top we have, so everything leads back here, right? So let's find diameter. We're done here. 32. Factor of 60 you can choose either between 2, 2.5, 3, but then if they don't give you, I think preferably use 2, okay? But then they'll give you, if you say it's a nice person, like my say, it'll give you, right? So here at the moment we use this one. The maximum is going to be 158.74 over, right, over the endurance stress. Do we have it? Do we have the endurance stress, nigga? Huh? Do we have it? Huh? Do you have it? Do you have it? No, but we're given the ultimate tensile stress. The ultimate tensile stress. So it's advisable to use it like this. Endurance is equals to half of the ultimate, right? Half. So instead of 1000, we're gonna use 500. 500 times 10, 6, right? Oh, let's go back to our formula. Go back to our formula. Go back to our formula. Formula squared, right? Plus 3. For at this point, we're just following the formula. Multiplied by the torque. The torque we found it is 84.88 over the yield. The yield we also given. Like I said, at this point we just substituting, which is the nicest part actually. 0770 times 10.6, right? Squared also. Square, nigga. Protect me. I swear a square plays a major role. It protects everybody, but then who's protecting me? Who's protecting? Then 1 over 3, right? And then also here. And then diameter. Final answer. Do not make a mistake while punching in the calculator, because you can do all this right and then punch everything wrong at the end. So you better not do that, bro. Take your time, relax, double check, because you'll see flames. 158.74, 500 times 10.6 squared, right? Plus 3 over 4, 84.88. 84.88. You see, I almost wrote 88,000. 770 times 10.6, right? Squared also, and then everything power 1 over 3. Yeah. All right. So the diameter is 0.0189 meter, right? And then now you can convert it into meters. You multiply by 1000, which is 18.9 meters. 18.9 millimeters. What the fuck? 18.9 millimeters. So you can say the 19 millimeters. You see, it's not so hard. I mean, it's not hard once you do the hard part. It's not hard, bro. All these papers now I have to sort them out. Okay, let's recap. Let's recap. First things first, we looked at the key. We found the tangential, the radial, and the weight, right? And the capping. And then we looked at the pulley. We found the tensions, the tension 1, tension 2, and tension 1, and the weight, right? And then we looked at our shaft in both directions. In the Z direction, no, let's do this one. In the Y direction, we found the bearings forces, like, and then we found everything, and then we ended up drawing a diagram and shear stress diagram, right? We found the bending moments in the y direction, and then we came in the z direction, did the same thing, tangential load, and then the tension forces, right? Found everything, and then drew up the shear stress diagram, right? And found the bending moments, right? And then we added everything to find the maximum. Where is the maximum bending moments? We found out that it's occurring at C. Then at the end, we plugged everything into our formula, our well-respected formula, right? And then we found our diameter. Yeah, that's how it is. That's how it is. In the next question, I'm gonna be doing a question whereby a pulley is in different direction. Like there might be two pulleys, and the other is pulling up and the other is pulling. So yeah, be sure to check in the next question. But then like that, cough is out.